Hello everybody. In this lesson we will be studying about probabilities and we will be focusing on finding the theoretical probability. We will also be trying to understand what is an experimental probability and we will solve some of the problems to find out the probabilities of various situations. So welcome to the lesson. In our previous grades we have also studied about experimental probability, and we noticed that the formula to find the experimental probability is the number of trials in which the event happened divided by the total number of trials. For example, if we take a coin and toss it 1000 times, or let's take we toss it 100 times, so what is the total number of trials? It is 100. And let's say that the coin lands up on heads 60 times. So the number of trials in which the event happened, if we were looking for heads, say the heads landed up 60 times. So the number of trials in which the event happened will be 60. So the probability of heads occurring in this event is 60 over 100, that is 0.6. So this is how we found the probabilities in our lower grades. Let us try to understand what is a theoretical probability. The theoretical probability, which is also called as classical probability, is given by the formula number of outcomes favorable to the event E divided by the number of all possible outcomes of the experiment. So this is a bit slightly different from the probability of experimental probability. So let's look at the theoretical probability by taking an example. Let's try this example. Find the probability of getting a head when a coin is tossed once. Also, find the probability of getting a tail. Now we know that the formula is number of outcomes favorable to E, the event, divided by the number of all possible outcomes of the experiment. Now when we toss a coin, what are the possible outcomes when you toss a coin? How many outcomes do you have? Either it could be a head or it could be a tail. So the total number of possible outcomes when you toss a coin are 2. Now let's come to the numerator. Number of outcomes favorable to the event. The event which we are looking here is the coming of heads. So how many heads do you have in a coin? There's only one. So the number of outcomes favorable for heads is only 1. So the probability of head when you toss a coin is 1 over 2. Similarly, the probability of the coin landing on a tails up. Total number of outcomes are 2. There's only one tail in a coin, so 1 over 2. So now you understand how to apply the theoretical probability for the example. Let's try another one. Let's try this. A bag contains a red ball, a blue ball, and a yellow ball. So there are 3 balls in the bag, all the balls being of the same size. Kritika takes out a ball from the bag without looking into it. What is the probability that she takes out the yellow ball? So let's figure that out. The probability of a yellow ball. The formula is the number of outcomes, the number of all possible outcomes. So how many balls are there in the bag? 3. And in the numerator, it is number of outcomes favorable to our event. What is the event we are looking for? We are looking for a yellow ball. How many yellow balls are there in the bag? There's only 1. So the number of favorable outcomes is only 1. So the probability of a yellow ball being picked up is 1 over 3. Similarly, what will be the probability of a red ball getting picked? Same, there are 3 possibilities and there's only 1 red ball. So also with respect to blue balls, the probability is same thing, is going to be 1/3. Now an event having only one outcome of the experiment is called an elementary event. In all this, if you observe, there is only one outcome. Similarly, in our heads and tails of the previous example, there was only one outcome. Such type of events where there are only one outcome, it is called elementary event. Elementary events. The sum of the possibilities of all the elementary events of an experiment is always 1. So for example, if you take the sum of all these 3, 1/3 plus 1/3 plus 1/3, it will always be 1. So also in our heads and tails example, the probability of a head was 1/2 and the probability of the tails was 1/2. You add them up, it's going to be, the sum is going to be 1. This is true in general case for all probabilities. So the sum of the probabilities of all the elementary events of an experiment is 1. What is an elementary event? An event where the outcome is 1. Now let's look at few more examples. Let's try this. Suppose we throw a dice once. You know what's a dice? It has 6 phases in a dice. Like for 1, 2, 3, 4, 5 and 6. You know the tool that we use to throw on a Ludo, the dice. It has 6 phases. The question is, what is the probability of getting a number greater than 4? So we are looking at the probability of getting a number greater than 4. This is our event that we are looking for. Now what are the total number of outcomes? It's going to be 6 because there are 6 phases. Now what are the numbers that are greater than 4? What is the favorable outcome? The event that we are looking for are the numbers greater than 4. And how many such numbers are there on the dice? There are 2. So the favorable outcome is 2. So when we simplify this, it's going to be 1/3. Now let's come to the second part of the question. It says, what is the probability of getting a number less than or equal to 4? The probability of getting a number less than or equal to 4. Let's label that as F. So that is going to be, the total number of outcomes is 6. The events that we are looking for are the numbers that are less than or equal to 4, and these will be the numbers. What is the number of outcomes? 4. Simplify, it's 2/3. Now if you observe over here, the probability of E plus the probability of F, that is 1/3 plus 2/3, is going to be 1. We can note one more thing in this example. If suppose P of E is the probability of a number which is greater than 4, then P of F will be a number which is less than or equal to 4. It is same as getting a number less than or equal to 4. So let's label that as not E, complemented as E. This will always be equal to 1. This is called the complement of the event. So if E is the event, E bar is called the complement of the event. So if suppose E is the event, the numbers greater than 4, then its complement is all the numbers that are not greater than 4, which is nothing but less than or equal to 4. And an event plus its complement will always be equal to 1. And we can of course use this equation and manipulate it in various ways. For example, we know that now probability of an event plus the probability of its complement is always equal to 1. So if we want, we can also represent this equation as probability of the complement is 1 minus the probability of the event. This is called the general form of the probability of its complement. So let's try a few more examples and few more points before we proceed. The probability of an event, if it is 0, that means it's an impossible event. And if the probability of an event is 1, that means it is a sure event. So always the probability of an event will be between 0 and 1. So the probability of the occurrence of any event is going to be always between 0 and 1. Let's take an example related to playing cards. Have you seen a deck of playing cards? It consists of 52 cards which are divided into 4 suits of 13 cards each. Spades is of this type, hearts, diamonds and clubs. Clubs and spades are of black color, while hearts and diamonds are of red color. The cards in each suit are ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3 and 2. There's no 1 over there. Kings, queens and jacks are called face cards. So these are just some of the terms with regards to a pack of cards. Now let's come to the problem to solve this. One card is drawn from a well-shuffled deck of 52 cards. Calculate the probability that the card will be an ace and the card that will not be an ace. Try it out. So let's come to the probability of drawing an ace card. So the probability of ace, let us represent that with an event E. This is what we are looking for. So total how many cards are there? 52 cards. How many ace cards are there? There are 4 ace cards. So that is the outcome we will get. So 4 over 52. Can we simplify that? It's going to be 1 over 13. So this is the answer for the first part of a question. Now can you guess what will be the probability of drawing a card that is not an ace? Probability of, let's label that as F, which is nothing but the complement of E. How many cards are not ace? It will be 52 minus 4 and that's going to be 48. And now we can say total number of cards 52. The possible outcomes of drawing a card that is not an ace will be 48. So 48 over 52 is 12 over 13. And if you verify, P of E plus P of F is going to be 1, which is the general case that we know. So this is how, pretty easy. You just have to know the formula, read the question carefully, and then figure out what's the event they are asking for. Let's look at this problem. 2 players, Sangeeta and Reshma, play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. What is the probability of Reshma winning the match? Very easy problem. Let's represent S for Sangeeta and R for Reshma. So the probability of Sangeeta winning the match is 0.62. The probability of Reshma winning the match will be 1 minus 0.62, and which is 0.38. So the probability of Reshma winning the match is 0.38. Very easy problem. Let's look at this. Savita and Hamida are friends. What is the probability that both will have different birthdays? Second, the same birthday, ignoring a leap year. So let's look at the question carefully. Out of two friends, one girl, say Savita's birthday, can be any day of the year. So we are considering Savita's birthday to be any day of the year. Now, Hamida's birthday can also be any day of 365 days in the year. Let us assume that these 365 outcomes are equally likely. Now let's come to the first part of the question. Different birthdays. If Hamida's birthday is different from Savita's, the number of favorable outcomes for her birthday is going to be 365 minus 1, 364. This is for Hamida. If Hamida's birthday is different from Savita's birthday, then the favorable outcomes for Hamida's birthday will be one of those 364 days. So the probability of Hamida's birthday, which is different from Savita's, will be out of 365, the favorable outcomes are 364. That answers the first part of a question, that the probability of different birthdays will be 364 over 365. Let's come to the second part. What is the probability that the birthdays will be on the same day? So if Savita and Hamida have the same birthday, then definitely the probability of Savita and Hamida having birthdays on the same day will be 1 minus the probability of both having different birthdays, right? Having different birthdays. 1 minus the probability of having different birthdays, we already saw that. It's 364 over 365. And that is nothing but 1 over 365. So the probability of both having the birthdays on the same day is 1 over 365. And on different days, the probability is 364 over 365. Pretty easy problem. Let's look at this. There are 40 students in class 10 of a school of whom 25 are girls and 15 are boys. The class teacher has to select one student as a class representative. She writes the name of each student on a separate card, the cards being identical. Then she puts cards in a bag and stirs them thoroughly. She then draws one card from the bag. What is the probability that the name written on the card is the name of, number 1, a girl, number 2, a boy? Very easy. Let's try to find out what is the probability of the card being picked up is that of a girl. Total, how many students are there? 40. What are the favorable outcomes of the number of girls being picked up? 25. And that is the probability of a card of a girl being picked up. Simplify, it's 5 over 8. Always give your probability fractions in the most simplified term. Now we can easily find out what is the probability of the boy. It can be 1 minus 25 over 40, or we can do it the same way. Total number of students 40. There are 15 boys. So it's going to be 15 over 40. That's going to be 3 over 8. So very easy. Let's look at this. A box contains 3 blue, 2 white and 4 red marbles. If a marble is drawn at random from the box, what is the probability that it will be white, blue, red? So total, how many marbles are there in the box? It's going to be 3 plus 2 white plus 4 red. That's going to be 9 marbles. Now let's find out what is the probability of drawing up a white marble. So probability of a white marble Total marbles 9. How many white marbles do we have? 2. So it's going to be 2 over 9. That's our first one. Let's find out what is the probability of drawing up a blue marble. So the probability of blue is going to be total number of marbles 9. How many blue marbles do we have? 3. So the probability is 1 over 3. Let's find out about the red marbles now. So the probability of red, total number of marbles 9. How many reds do we have? 4. So it's 4 over 9. Now, if you observe over here, 2 over 9 plus 1 over 3 plus 4 over 9 is going to be equal to 1. You see that? Always the probability when you add them up, it has to land up to 1. Let's try this. Harpreet tosses 2 different coins simultaneously. Say let us say the 2 coins are one coin is of head and the other coin one coin is of 1 rupee coin and the other is of a 2 rupee coin. What is the probability that she gets at least 1 head? So we write H for head. Let's take H for head and T for tails. When 2 coins are tossed simultaneously, what are the possible outcomes? It could be 1 head in 1 coin, another head in another coin, or head in first coin, tail in the second coin, or tail in the first coin, head in the second coin, or both tails on both the coins, which are all equally likely. Now here, head means head up on the first coin and head up on the second coin. Similarly, HT means head up on the first coin and tail on the second coin, and so forth. The outcomes favorable to the event E, at least 1 head, that is what we are looking for. The probability of at least 1 head. At least 1 head. What is the probability? We have how many? At least 1 head. At least 1 head and at least 1 head. So out of 4, there is the number of favorable outcomes are 3. So the probability of tossing at least 1 head is 3 over 4. Excellent. This is how you solve the probability questions. Thank you for watching this video. This completes the lesson on theoretical probabilities. I hope you understand it, and I recommend that you take up more problems and work on this. Thank you for watching this video once again. Please subscribe and share to this channel, Wisdom Outlined. Thank you.